Hi, welcome to Nomis Academy. In this video, we are going to be looking at cycle theorem and we are going to consider theorem 4. In previous videos, we've been able to state and prove theorem 1, theorem 2, and theorem 3. So in this video, we are going to state theorem 4 and also show the proof. Alright, so let's state the theorem. It says that the angles in the same segments of a cycle are equal. Okay, the angles in the same segment of a cycle are equal. That's theorem 4. So let's take the diagram to explain it better. Okay, this is the diagram. At this point, this is the center of the cycle O. Okay, we have an arc AB which forms angle at this point. Okay, so we call here X, and then also subtend another angle at this point on the circumference, so we call here Y. Okay, so you can see that two angles are formed at the same segment of the cycle. Okay, when we talk about segments, when you divide a cycle with a chord or by a chord, let's say this is a chord, the chord divides the cycle into two segments, the major segment or the minor segment. So now you can see that if you should draw a chord here, you can draw a chord. You will agree with me that the chord forms two segments and this is the major segment. So you can see that angle at X and Y are on the same segment of the cycle. So the theorem is saying that these two angles are the same segments formed or subtended by the same chord or an arc are equal. So then let's go straight to the proof. You remember the procedure? Given. What is given to us? Now we have cycle A X Y B with center O. Okay, so we are giving cycle AXYB with center O. Let me clean the chord so that we can see things clearly. Okay, all right, so now we are to prove that angle AXB is equal to angle AYB. So these two angles are in the same segment. We are to prove that the two angles at X and Y are equal. Okay, construction. Okay, in this construction, we are going to join A to O and B to O. So join A, O, and B, O. So let's do that. We are going to join A to O and O to B. Okay, so we continue with the proof. To prove, now let's start. Now we consider the angles AXB and AYB. Now you agree with me that AOB, which is the angle formed at the center, angle formed at the center is equal to 2 times the angle formed at the circumference, which is AXB. That is 2 times AXB. So let's write the statement. We say angle at the center is equal to twice the angle at the circumference. Okay, so we have that. Also, again, we have that AOB, as you can see, AOB, that is angle formed at the center of the circle, is also 2 times bigger than the angle at Y, which is AYB, as we saw it in Theorem 2. So we also make the same statement. Angle at the center is equal to twice the angle at the circumference. So if AOB is equal to 2 times A and AXB, angle at X, and AOB is also equal to 2 times AYB, angle at Y, then we can equate the two together. Let's call this equation 1 and we call this equation 2. So let's move to the other side of the board. So let's equate the two. Equate equations 1 and 2. So to do that, since AOB is equal to this and AOB is equal to this, so we can write 2 times AXB is equal to 2 times AYB. So divide both sides by 2. So you can see that 2 cancel 2. So we are left with AXB is equal to AYB. So the angles formed at the same segment of a cycle are equal, as proven. So this is the proof to Theorem 4. Once again, we say that the angles formed by a chord or an arc at the same segment of a cycle are equal. So this is the proof. So thank you for watching. See you next time. Bye.